All right, so last time we were talking about, and if you'll just give me a second, I have to just plug in my laptop. And again, part of the reason I come in here and I'm slightly disorganized is that I'm running from 1068 before I get here. So, are there any questions from the homework that I really need to address? No? All right. So, hopefully it shouldn't be too bad. I'm going to try to discuss with my TAs today basically everything that needs to go on for these things and when appropriate due dates are. So let's jump right in and talk about, so I'll have to actually stop the automatic scene switcher for a bit because I'll have to go and use the Firefox. But anyway, did we go over the list interface last time? Did we go over like what the interface had? Like, did we go into the actual interface source code, right? I think we wrote an interface, right, in class? We wrote a interface called the shape, and then we created a circle that was the shape, right? Awesome. So, and the great thing about these is that there is the amount of polymorphism that can just go into them. So let's go ahead and I'll turn this to just screen and let's see. Yeah. Okay. So that's I'm just gonna have to switch this off for a second. Stop. So let's go ahead and look at the, doesn't look too professional when I'm trying to configure this while it's recording, but whatever. We're doing it live. So, so let's go ahead and look at the list source code. Okay. Okay, and as you can see, since it's already super zoomed in, I've been here before, so so you can look at anything in the source code. Did I go over string last time? Did I look at the string source code? So let me go ahead and look at the string source code Java, because it has a couple of interesting things that we can that we want to just finalize here. So right, everything that's written in Java has source code in Java. So here, string, and it turns out that a lot of this is java.comment, which means that it's comments with /**. So it's a multi-line comment with an extra star, which means Java knows to look and that it can create documentation automatically from it. You remember those API pages in Java that they have that goes through every single method they have? Those are generated by these things, So this is just some basically ways to automatically generate HTML. So a lot of the code over here, a lot of this is just comments. Okay, here's the license saying that Sun made this. Here's all their import stuff. It's in the java.lang package. Here's all their imports, right? Description of what the string is. So let's look at and we can look at this. Public final class string, and then it has an implements of a bunch of other stuff. So, okay, that's interesting. We haven't seen final used like this before. So first off, where the context we have seen final is like public static void, sorry, not public static void, but public static final double pi, right, is equal to 3.14159. So what does final mean in the context of like when we use it on a variable? Yes. It can't be changed. It means that once we set it, it can't be set. So final pretty much always means it cannot be changed, right? That's the meaning for final. So if we see final class, okay, over here, and final means can't be changed, what do you think that means for a class? If it's a class that can't be changed, how can a class be changed? Think it goes into inheritance, right? Yes? Right, inheritance. What does that mean in terms? So what does that probably mean if a class is final? You can't inherit the class. That means, and that's actually kind of smart. That means that I can't write my own string class that's like somehow malicious or something, right? And then because of inheritance, I would have been able to use malicious string wherever a string was valid, right? Right? So this gives me, so final over here gives me control and says, no, you cannot extend this class. This class is, it's perfect. Don't change it, right? So you can't inherit a class that's final. Likewise, you can have a final method. Let's see if this one, so here's an array. I don't know if this one has a final method or not. So if a final class means it can't be inherited, what does a final method mean, do you think? because it exists in the same context. What's a final method mean? Yes? It cannot be overridden. That's exactly right, right? It was a shot in the dark, but that's exactly right. It means that, so if you write a final method, same thing. You cannot override the method. It's a way to protect stuff, you know. So it's kind of the reverse of abstract. Abstract means, so, right, an interface is like a completely abstract class. And if we had abstract here, that would mean you must inherit this class, right, in order to use it, right? You must override everything in it. Abstract methods like the ones you see in interfaces. I mean, those you know, all the method stubs in an interface, the get area and the get perimeter. Those basically said you have to, please for the love of God, implement these. Okay, so final means don't change this. Abstract means you gotta change this. You know. So this implements three interfaces, right? That's no problem. You can extend as many interfaces as you want because there's going to be no conflicts, right? It has serializable, char sequence. Those are things we're not really going to concern ourselves with. This one we'll eventually see ourselves where it says comparable, and then it's got that weird generic thing we were talking about earlier that I said I'd get into today, you know, because I really can't avoid it. But it says, but basically this means is that strings can be compared to other strings in a meaningful way. That's all that means. Okay, and the way we're going to learn that one is about comparable is like looking at stuff that's already comparable, and so much stuff already is, it makes it super easy. So, but we can look at the source code, see that the string has like an offset account and a value variable. That's all that gets set up in the constructor. And then if you pass a string, it does it. So there's a lot of stuff here. So let's go ahead and look at the code for the interface list instead. Okay, public interface list E extends collection E. All right, so what does that mean? So first off, this is where the whole the E's mean, and I'll go through a more concrete example, but the E's mean this is where the generics come into play. Okay, when you see this E here, that means this E is a placeholder, right? When I create a list, I won't say list E, I'll say list of integers or lists of strings. Okay, and whatever gets put in those brackets will get replaced over here. So when you actually create this, it will replace all the E's with like string or integer or double or whatever I told it to replace it with. Okay, so extends collection. So this is an interface. Interfaces can extend other interfaces. They can have parent interfaces, like saying that this list is a collection interface. That's not something that we're really going to do, and just like we're not really going to write interfaces, it's just I should mention that that's what's going on there. Okay, and again, an interface is just a list of methods and maybe a couple of static variables, final static variables. So it has an integer size, right? That just simply says return the number of elements in the list. Boolean is empty. Returns true if it has no elements, false if it has no elements, right? You can see exactly how you might want to implement that one using this one. If the size is 0, you know, then return true for is empty, right? So that's pretty easy to see how to implement that. Contains, whether this contains some object. In iterator, there's that E again, but remember that's going to be replaced by string. Okay, object to array, that just simply turns this list of stuff into an array, right? This one's weird because it's got the T, you know, it's got this weird thing. That's just some weird generic stuff that we're going to have to bat our head against in lab. Add, so this one over here. This was the important thing. Boolean add E, capital E, lowercase e. And all this means is that, and we're going to write our own basic generic class to make sure we get an understanding of this. This just simply means that if I enter in a E, like the string over here, like if I put in string when I created the list, like a list of strings, this E over here would be replaced by string. If I put in integer, it would be replaced by integer. This adds only of type E, and this just simply uses lowercase e because we like to be shorthand like that. So in the E, I think here we could just use, if you need something, you can stand for element, right? Adds this element to the list of type E, where E is defined whenever the user makes it. Okay, so there's all these methods. There's like 23 you have to write. So with that said, so we should probably let's go ahead and just show you a bit more about generics and how to make them. So I'm just trying to remember which one I'm working in. So generics, here we go. Generic example. So I'm going to create a very stupid class that's kind of useless, but we're going to turn it into something else later. So let me go, and let's go ahead and just start the automatic scene switcher back up now, because now I don't need the web browser anymore. Okay, start. So there we go. Okay, so we're going to call this the box class. Okay, it's kind of a very stupid class, but it only exists to handle generics, and we're going to just show you how that works. Okay. First, we're going to show you what happens when we don't have generics, and then we're going to show you what happens when we can have a generic. Okay. So a box is a really stupid class because all it's going to do is going to just hold some data. Okay. Right. We could just pass in that data itself, but maybe boxes are special for some reason, and they will be in a bit. Okay. They're just going to hold some data. Right? And since we want this box to hold any kind of data, right? What type should I use if I wanted to hold anything? String would only be able to hold strings though. Object, right? So I'll get up to generics in just a second. So object data, that's all it is. I'll leave it, and even though it's bad karma, I'm going to leave it as you know, not public or private or protected. It's just going to be blank. What that means is that this is like the fourth access and modifier option, right? We had public, we had private, we had protected, and now we've got this nothing there, which simply means that it's public to everybody in my package in the same folder as me, right? So now I can just simply use this over here in our generic example. So I'll create a method over here so that we don't erase too much over here called public. Let me go ahead and save this. Void box. Actually, let me just create a new class because it makes more sense to do that. Class box example. Yeah, you're super organized today. So let's go ahead and say. So these things are easy to create, right? Box B is equal to new box. There's nothing to it right now, right? Nothing. There's nothing in the, there's no special constructors. It just sets the data equal to null. And if I want to set it to something, I can go B dot data is equal to, can I do 5? Yeah. Can take this. So I can, even though it stores an object, I can take a primitive and store it in there. Why? Because that primitive, right? We take this primitive. It gets converted into a integer object, right? The int gets converted into an integer object, right? The wrapper class. And we went over the wrapper classes briefly, right? Right? So it's converted into an integer object, and then that gets stored in there because you can store an integer object in an object field because it's an object. Have I lost anybody yet? I want to make sure because it feels like I had the evening lecture, which was twice as long, right? And then I had your guys' lecture, and it feels like you're at the same space right now. You're at the same one. So I'm gonna have to double check to make sure I'm not glossing over anything. It feels like in one lecture I managed to do everything in that lecture, but that sometimes happens in the first week. Okay. So now let's go ahead and create a. So now the issue was that we were having with generics was if I wanted to get out an int, right? Int x is equal to b dot data, right? I know this is an integer. I just created it. But Java doesn't know that. It says it's an object. You can't take that object and stuff it into an integer, right? That's what it's saying. So the issue is that I have to cast it, right? I have to say that's actually an int in there. And, you gotta run for me. System.out.println x 5, right? That's what we've got. So we have that, and that's, but of course I could be wrong. I could think, I could say that's 5.0, and let's see what's going to happen there. We can be safe still. Nope, you can't take a double object and cast it into an integer. You just can't do it. You can't swap them like that, right? Even though I know it's an int in there, I can't do that, right? I can't do that typical casting. I normally can do, even though I know it's a double in there, right? And that makes it just really frustrating to work with, okay? So, because there's ways to basically shoot myself in the foot and also ways for me to accidentally make mistakes. And then even if I'm not, I still have to cast everything, right? Which is tedious and annoying. So instead what we can do is that we can say that this is a box that holds something, a box of E, of type E. Now E is typically used over here. This just simply means that it's of it's of type element. Sorry, of type E. So, and what I do instead of switching it to object is I just simply say it's this data is of type E. It's the same thing that gets put over here. That makes sense to everybody? This over here, E, and this thing over here, when we create a box object, it's going to be the same type. So now let's go ahead and switch this back to a working example. It's going to, if I don't use generics, it's going to work exactly the same way as it did the first time, which is that now it says that I've got a warning saying box is a raw type. It should be, you should add a generic parameter to it because it uses generics. So what we do is that if I don't use the generics, first off, you have the option of not using generics. You shouldn't, but you have the option of not using it, okay? Right? It compiled just fine. If I don't use it, Java's like, I don't know what goes in the box. You didn't label it, right? So I have to assume that anything goes in the box. So I'm just going to silently do this. Object, right? I'm just silently going to replace the E's with objects, right? And that way I can know what's in the box. That way you can put anything you want in the box. So here it's something, we put something, we put data, we set data to 5, we put the 5 in the box, and then we have to tell it, well, it's not an object in there because I didn't label it, so you have to think it's an object. Then tell it it's an integer, right? It works exactly the same if I don't use any generics. But now if I use generics, what I can do is I can say there's an integer in this box. This box holds an integer. Okay? This box holds an integer. So now I can store this integer in here, right? And get that. Okay? So I'm going to show you, so how does this work with methods? Let me show you how it works with methods, because that's kind of important over here. Okay? How does this work with methods? So let's go ahead and say, let's say I was actually doing this right and made this private, So now I can't do this, right? It's private. I can't say b.data is equal to 5 and x is equal to b.data, right? I have to use a setter and getter method to do those. Okay? So how does that change things up? Okay? So again, let's go ahead and look at it where we don't have the generic, and then I'll put the generic back in. Okay? So if it was a setter and getter thing, it would be, let's see, public get, right? So it would be some type get data. And return data, right? We would just say return this.data, and we need a return type. Well, it's an object, right? Because this box holds objects. And same thing with the set method. Public static, sorry, not static, but public void set data, which takes in an object, right? O, and this dot data is equal to O, right? That's how it would work without generics, right? That's just the standard getters and setters. You match that up. So now, so that's not what we're going to use. What we're going to use, of course, is generics, because that's what we're trying to teach. So now what if we have a generic, we use generics, and this is E instead, right? This data is of type E. Well, that's pretty straightforward, as you might imagine. It's as straightforward as you think it should be, which is that anywhere you see an object, you just simply replace it with type E, right? Data is of type E, so in public E get data, we return this.data, right? And the E is over here because this.data is of type E. That means that if this is set to a string, get data is going to return a string. If this is set to an integer and data is an integer, then get data will return an integer. You see how that's useful? It will modify the return type on the fly for us, essentially. And over here too, we can change the setter so that it sets data and say that this data of type E and the data that's passed in as a parameter of type E matches. So now I can do, so it's a box that does an integer, and now we can look at the method calls. B.set data. It says integer data in that rather than saying E data, right? Or object data. It says it is an integer. So set integer to 5. And then x is equal to b.get data 5. Or get data rather. Right? So we're getting the data. And we're storing it. And we're going to print out x. 5. Right? There we go. That works out pretty well. Right? So that's really useful. And if I change this to a string, right, change both sides to a string, it's going to say, hey, this won't work because you're trying to put in, the method is set data string, right? It doesn't take in an integer. You're wrong, right? And it says over here, b.getData, that's going to give you back a string and you want an integer? That's not going to work, right? So you can see how this helps prevent things. It prevents the need to cast. So that's pretty useful. So all that happens, right, when we create a list of something, like a list E of something, is that it just changes all the methods from being type E to type whatever the heck we wanted it to be. Okay? So that's pretty useful. All right. So we've been talking about lists, and we say that lists do all these things. They obtain elements at specific positions, right? You can grab anything from the middle of a list you want. You can swap out anything you want in a list. In other words, you can set and get things in a list. You can set any index to something in a list, get the index of anything from a list. You can find where a value is in a list. You can add and remove stuff wherever you want from a list, and you can, put it anywhere, put something you want anywhere, and go through the entire list. Okay. So this is the whole. Unlike the arrays, you can't use, right. So a list, because it uses generics, you can't store ints in it. You store integers and you store capital D doubles, right. So we're going to learn about the array list to start out with. Now, the array list for this week's homework on Thursday and Friday, this will basically be a lot of like the methods of what the homework you had to do when you were using arrays, or the types of questions you got on exams when you were learning arrays, which is that you're just going to like give me the average of the entire array. Instead, it's going to be give me the average of the entire array list kind of deal. So those kinds of questions. That's what this week's homework is. And we're going to be working with static methods, which are a bit weird with those, but let's go ahead and go work through a couple examples of how the ArrayList class works. Okay, so to declare so this is going to be go through the code first, and then what we're going to do is after I go through the code, I'm actually going to write an ArrayList, a pseudo ArrayList, because it's not going to be like a real ArrayList. I'm just going to write the important parts of an ArrayList from scratch. Sound good to everybody? Rather than just going through the slides, because that's boring. But here I want to go through the slides because they've got, pictures and stuff, and pictures are pretty, right? So, all right. So declare a list object whose elements, not elephants, will reference string objects. We will create a list of strings called myList, right? So this is myList is a list of strings, right? So that's an interface on the left. But using polymorphism, we can say because an array list is a list, we can say that this variable holds a array list. Okay, so we're just creating a new list, and we're implementing the list using an array list, and it holds strings. So lists by default, they're empty, but they have what we call capacity, which means how much stuff they can hold without having to shuffle stuff around. Okay, without having to do anything extra and do some hacky stuff. It's going to hold just up to 10 elements. So to add strings to the list, we would say, add bashful, add awful, add jumpy, add happy, or it can be adding dwarfs if you don't get the reference. So doing that, my list will look like this: bashful at index 0, awful at index 1, jumpy at index 2, happy at index 3. So if we're going to add in, but we can also, that's if we provide one argument for add. Add is overloaded though. We can, if it actually has a couple of, there's actually a couple different add methods, but don't, like literally this one and now this one. To add an element with subscript 2, in other words, to put this in where index 2 is, I can say add the index I want to add it to and what I want to add. So add doc to index 2. So this is before, and after it's going to look like this. So mylist.add to doc. We got bashful, awful, doc, jumpy, happy. Okay? So notice that basically that when we put in doc, jumpy and happy, they move from 2 and 3 to 3 and 4, right? That's straightforward. So if we don't have a subscript, we add something to the end of the list. So we just simply add dopey to the end of the list. There. So this one, right, adding dopey just adds dopey to 5. Just like how, so in other words, bashful added this to 0. This went to 1. This went to index 2. This went to index 3. It just simply adds it, just slaps it on right at the end. Okay. Removing an element, you specify what index you want to delete. You don't specify like an individual element you want to delete. You say, I want to remove this. I want to remove the index 1. So if I remove awful, which is not a dwarf, probably. I mean, maybe there's expanded dwarf lore that has like awful being a dwarf, but my list.remove 1. Let's go ahead and remove, and that will change this. And notice that the subscripts of doc and all the things following after change from 2, 3, 4, 5 to 1, 2, 3, 4, right? It automatically adjusts the indices in the list, which is kind of the behavior we want. We can also replace elements that we want. We can do mylist.set, and that just simply says take the thing at this index and replace it with this. So once this executes, jumpy gets replaced with sneezy. That makes sense? We can just replace stuff using set. And if we need to access something, here's the first big pitfall that I see, that like you don't understand array lists, okay? Or maybe you just had a bad day and forgot. But you can only use the subscript notation, which is this over here. You can only use, let's actually use a pointer just to super emphasize this. You cannot use this notation on an array list. You can only, or any kind of list. You can only use this array, this bracket notation on an array. This only works on arrays. Instead, to use this, you have to, if you want to do something like this on lists, you have to use the set method over here to set something, or you use the get method to get something. So get an index 2, mylist.get2, gets sneezy, and stores what it does is it stores the memory location of dwarf that was the memory location that was stored in this index over here. So they both now reference sneezy, right? Both of the things are now sneezy. You can also, what's pretty cool though is that you can search for an array list. You can search an array list for stuff, which is like, it has this nice method, index of. So tell me the index of sneezy. That will return 2, right? That makes sense. So you just you just say what you want and it'll return the index of it. Now, if you can't find it, say that it's looking for jumpy over here. Notice that this doesn't have jumpy, right? So there were a couple design decisions of what we could do with that. One was we could throw an exception and crash the program if you can't find something in the list. What Java decided instead was we'll report a normal index if it's the index that it's at if we can find it, but if we can't find it, we're going to return -1. Okay, so if you can't find something in Java in an array or an array list, the default value that gets returned instead of an error is -1. And then basically if you do try to search for -1, of course, that's going to cause an index out of bounds exception because you can't find, a -1. So that what's important. Now, the reason I'm emphasizing this is because Python does it differently. Then this is the bit where like 70 to 90% of a programming language will translate over to another programming language, right? Then there's all these little exceptions. In Python, negative indices are used for the last element, to go through the list in reverse. So -1 will get you the last element of a list in Python. -2 will get you the second to last, and -3 will get you the third to last because Python decided, why not? We can and that's actually useful sometimes, but sometimes it's just really annoying. But in Java, -1 is out of bounds. Okay? So going back into generics, list string, my list, new array list, it uses generics. Now, not every language has it. Go, the Go language that was written by Google is notorious for not having a generics, and it's one of those things that that seems really complicated and is a pain in the butt to learn, but it's one of those things you really miss when you don't have it in a language. That being said, there are only 2 types of programming languages, right? Some people say like procedural, functional, logical, those kind of things. No, there's only 2 types of languages. There's programming languages that people complain about, and programming languages that nobody uses. So so that's not my quote. I forget. I think it was Bjorn Strusup, but I might be misremembering. So if somebody wants to correct me, you can leave a comment in the video. So harks back to the first lecture where I say basically if you want to get information as quickly as possible, make a mistake. So yes.
Is the index of method, does that use the equals method of the class?
It does. Yeah. It will. Yeah. We'll use. I think it uses the dot equals of whatever you're storing, right? So this statement is generic collections, right? It stores a list of strings, and only strings can be put in here, right? And basically throughout our class here, for basically all the data structures writing, this is the generalized way we create stuff. The class name, whatever we want to put in it, is equal to new, whatever that class is, and whatever we want to put in, open parenthesis, close parenthesis. This is what we call the type parameter, and this handles the auto boxing sort of thing. And basically, like array list, my list is equal to a new array list of integers, right? We can add a new integer, right, to this class. We can also add, just an int, which gets automatically put into a integer, right? But if we try to add a string to this sucker, it's going to crash and burn, right? Because it's an array list of integers, right? So again, why do we use this? We saw that we don't need to cast anything in our examples. It's easy to it catches like errors that you might make earlier, because if you try to add a string to a list of integers accidentally, we will basically detect that immediately, as opposed to later when it's late at night and you've got a massive headache because you haven't gotten sleep, and now you're trying to pour through the 100 lines of code that you have, trying to figure out why it compiles but why it doesn't run. Well, this will prevent it from compiling. And it also documents your intent, which is important. It tells the reader of the code, and the reader of the code is extremely important because that's often you, but in the future, what you meant to do. And if you try to remember what you did last week, you may have had this experience where you tried to go back to your code that you did and you could not remember for the life of you what you were trying to do because you didn't write any comments on it, and you named everything X, Y, and Z, and I and J, and your variable name you just couldn't figure it out. Well, this helps you figure it out. So, all right. So here's the methods that I'm going to try to write from scratch for us. The get, the set, the size of our array list, add at a specific index, find where something is, and remove it from there. Okay. And array list, it goes into applications. The slides go into the applications of array list. But if you can think of where you'd like to have an array that just automatically sizes itself, those are exactly the applications you might have. So, right, here you have an array of integers, and you can just add those ints. You can sum them up, right? But also, like over here, you can create more advanced stuff. So say you have a phone directory, like the type you keep in your in a cell phone where it maps the names and numbers, right? We can create a class, and then that stores a name and number, and then we can take that and we can store it in there. So an array list of these things, which contains 2 strings, and then we can add a new directory entry that has those 2 things there to it, right? Jane Smith and then her number into this directory. Yes.
So can you add just Jane Smith and those numbers without new directory entries, since you could do it in that other example with integers?
Well, you can add it to integers over here because these are integers, right? But you need since this is a list that holds directory entries, and a directory entry is 2 strings, right? Yeah. So they want to be held in the same slot together because they need to be kept together. Then this is the way to do it. You can't just not give when you create an array list of directory entries, that's the only thing you can put in here.
Oh, right. I meant like literally typing new directory entry.
Oh, yeah. You can add it just like this, or you can create like entry E is equal to new directory entry, Jane Smith, and that stuff, and then add E over here, right?
Okay, but you can't not put new directory entry and then those.
Right, because you have to create a new object for this. So let me go ahead and go into this. So what we're going to do is that we're going to implement a array list from scratch. This will be a pretty simple implementation, so I'm not going to implement all the list methods. So it technically is not going to be a list as Java considers it, but it's not hard to completely add all the features to it. And I'm just going to use this one, just the beginning of it, because I want to make sure I get this right, because this is a bit of a hack that I have to do at the beginning. Okay, so let's go into Eclipse and start writing it. So let's go ahead and write our own list. I'm going to just call this surprisingly, and I'm going to put this in the list package, my array list, because it's not actually an array list. I'll create a main just so that I can have a main, right? And I don't want it. I normally, if I was writing a list, I'd go, implements, list, right? And I don't want to do that because then I've got all these methods I have to write, and that's going to be a pain in the butt, right? Of a lot of, I'd have 23 methods that I need to write, and not all of them are super important. So the other thing is that my array list is going to hold specific things in it. So I want it to be generic, right? Hold an array list of some type, right? E. Now, you're like, can I put anything I want in here? Let's go ahead and check the box. Back to box for a second. Yeah, single letters you can totally do. You can do T if you wanted to, although T has a different meaning. It's just convention there. But I could put like thing in here, and that's perfectly fine, right? It's just we just simply use a single letter for convention, right? You can put whatever you want in there. Like by convention, we're going to use E a whole lot here. Okay, so it's a list of E's. Now, this is an array list, which means I'm going to actually, what I'm actually going to do is cheat. And I'm going to do that for a couple data structures when we write them. And this is how an array list works, right? We mentioned that basically that an array list does all those things that an array can't, like grow automatically. And it acts like an array. Well, that's because it's actually an array, and it's just handling all those stuff that basically that would be really hard to do in an array for you, like shifting stuff over. That happens automatically. So let's go ahead and create our instance variables first. First, we need a place to store our data. The easiest place to store the data is in an array. What's the array? Well, it's going to be of type E. So this is going to be an array of whatever gets replaced in here. So if this is strings, this is going to be an array of strings. If this is integers, this is going to be an array of integers. That makes sense to everybody? So E data. Okay, so, and it's private because we don't want people to manipulate our stuff automatically. Okay, next, we're going to keep track of the size. So private int size, right? How big this array list is, right? How big is this? It's going to be however, that's equal to how many things are in it. Also, we're going to have something called the capacity. We don't need to keep track of this, but we're going to have is something called public. Actually, let's change this up. Public static final int initial capacity, which is how big does this thing start at, right? How big do we want our array list to be at the beginning? And that is, we're going to say we want it to be 10 big, right? In the beginning, we want it to hold 10 items. If we need more than 10, then we will figure that out later. But for right now, 10 items is good. Sound good? Okay. And then we create a separate, and we'll create a separate variable just because for the actual capacity. Now, what is the capacity? It's literally how many things we can store in this array over here, the data array. Okay, it's literally how much we can store in there. Okay, so the first thing we have to do, which is I always hate doing, and if somebody knows a better method to do this with the constructor, then let me know. But getting the constructor to work is a bit of a pain in the butt. So what I have to do is I have to say private. So let's go create our constructor. So let's build it. So public my ArrayList. Okay. So first off, we're creating an empty ArrayList, right? So that makes the figuring out what our size should be pretty easy, right? This.size is equal to 0. Okay. Next thing we have to do is create our data array. So we'll say this.data. Now, what I would love to do is this. New E. It's an array of new E's of size 10, right? And I would love that would work, except that it doesn't. It says that you cannot create a generic array, which is really weird because you can use arrays like that, but you can't create a generic array like that. That's annoying. You can't just like say, you can't do that. Instead, what we have to do is say, create an array of objects. And I believe this is what I have to do. And then cast it into E's. Oh, and it's not 10, right? Because what we're going to have is that it's going to be initial capacity, which is 10, right? Now let me go ahead and make sure that this works. Okay, because always make sure your code works before running on, because otherwise you might come back to an error that you have to go back to. So my ArrayList list is equal to new my ArrayList. Okay, and we're going to create an ArrayList of strings. Okay. Okay, and let's just go ahead and run it and make sure it doesn't crash. Okay, it did not crash. If it did, it would have given me something on the console that said it would have crashed. So we're good so far. So this is annoying, this whole thing. It's not really something you're going to have to worry about because I'm not going to make you program your own array list. Instead, what do you think I am going to make you program is your own linked list. But for array lists, we more care about how to use them. But understanding how they work, opening up the hood of the car and looking at the engine, so to speak, lets us, build up muscles, some programming muscles. So here we have our constructor. All right. So let's go ahead and work on our size. So do we want a person to be able to manually set? Hold on one second. One more thing. This dot capacity is equal to initial underscore capacity. And maybe if we want somebody later to come in and, maybe provide an integer to say, actually, I know I need more than 10 items. Can you just go ahead and allocate, 1,000 items for me? Maybe later we can have a constructor that does that, right? Because that's what the array list has. It does have a constructor where it says, I need more space. So instead of starting with the initial of 10, give me more to begin with. All right. So first, let's go through these things and figure out, what do we need? We don't want a setter for the size, right? We don't want somebody to come in from outside the program and set our size and say, you have 12 things in there and really have 1,000. And now that messes up the entire program, right? So instead, I don't want somebody to set it. But somebody able to see how big it is, that's probably pretty useful if they want to write a loop to go through it. So public int size. Normally it's get size, but size is the way that all collections work, where it just returns the size. And this capacity here, which is how big the data array is, that's completely private. I don't want somebody else to see it or set it. So that's one done. There was an isEmpty method, if we recall correctly. So public boolean isEmpty, right? That's pretty easy to figure out if we have a size, right? If we have a size variable, we can just simply say, and I'll condense this. I'm going to write it longer, and then I'm going to write it shorter. So this dot size is equal to 0, right? Return true. Else return false. Now, one of the things you should know. So let's go through this. If the size is 0, then it's empty. So we return true. If it's false. So if it's not, if there's more than one thing in there, we return false because it's not empty. That's great. But really, let's see if we can't shorten this and make it a bit more efficient. If this dot size equals 0, so if this Boolean expression evaluates the true, return true. If the Boolean expression evaluates the false, return false. We can skip this whole step and just instead return the Boolean expression, the result of the Boolean expression itself. So instead, we can just shorten that to one line and say, hey, return the result of checking is this 0 or not, right? If this is 0, so this will return true if this dot size is equal to 0. Otherwise, it's going to return false, right? That makes sense to everybody? You can a lot of times you can take an if-else statement like that and just break it down into a single line. If you're doing a basic return statement. All right, so I'm going to avoid the quote-unquote hard methods for as long as possible, which won't be that long. So let's work on get and set. So remember, this is just an array that works underneath this. So public E get. Now, why are we returning E? What does get do? Get says give me something at give me the item at integer index, right? So this says return return an item that's at this index, and it'll be of this type. Okay. So we can just simply say, okay, E item is equal to and because there's just all it is an array underneath it, right? All we have to do is just say data index, get the item from there, and then return the item, get the item that's stored at that index and return the item. Pretty simple, right? However, there's a place where where this could fail, right? What if index is negative, or if it's an out of bounds kind of deal, right? That's something very important that we'll have to check with. So why don't we check that for here? If index, so what's a too small index?
Less than 0. Yeah,
if it's less than 0. And what would be too big for the index? Right, this is an array of size. How can you tell if it's out of bounds?
It's greater than size minus 1.
If it's greater than size minus 1, or greater than or equal to size. Either of those work. I mean, we're dealing with integers, so either of those work. So if index is greater than this, or greater than or equal to size minus 1, and I prefer to keep out minus 1s if I can. So if it's greater than or equal to the size, right? The size of the number of things in it, if you remember. So say we've got an array and it's got, it's got our items at, it's got in item 0 at index 0, item 1 index 1, item 2 at index. Do you need me to move this out of the way or something? 2, 3, 4, 5, right? This is a size 6, right? This is a size 6. So if I try to get something that exists at 6, it will go, okay, let me look for the number at index 6. Oh, that doesn't exist, right? Size 6, meaning it has indices 0 through 5, if you remember, right? So if we've got that if statement, let's go ahead and see what else we can. So what can we do? Well, we can throw an exception. We can tell the user they're an idiot, okay? So now typically what happens, I think, is like an array out of bounds exception, right? So, oh, wait, and because it's an object, I have to say new array out of bounds exception. And let's see if I change to array index out of bounds exception. There we go. And that just simply says create an error. Let me scroll down. Okay, so there we've got, could also do an index out of bounds exception. We could also create our own exception too. New class. Remember, everything's an object, including exceptions. So new peb pebcac exception. We really want to be insulting. Problem exists between keyboard and chair. That's what that means. So, so let's go ahead and, that's going to be, we're going to simply, and all we have to do is now inherit from our, in order for this to be an exception, we just say extends, let's see, I think runtime exception if we don't want to, basically it's an exception that can happen at runtime. That's all we need to do that, and now instead of throwing any, so now we could add some extra stuff like the error messages. I'm not going to go into that, but now if I wanted to, I could say it's a pebcac exception. Right. And that, yes?
So you're sending the exception back to the
yes.
Whatever
yes.
method called the...
And the reason I'm doing that is because over here is that because if I want to change what the exception is, right, if I didn't do that, it would still crash and burn over here, right? Was that your question?
Yeah, I mean, could you do a try catch?
I mean, I could, but I want to send it back to the user, and basically, if they try to do an illegal operation like that, they probably want their program to crash, or for them to handle it in their own try catch up the chain. Okay, so here let's go ahead and do list.get 0, which is greater than or equal to the size of the current list. And so now if I run this, it gives me a get exception. It says, hey, you've got a pebcac exception, right? Now, mind you, like stuff like this, like typically we don't want to do that. Instead, we want to use something that gives us a bit more data, like the index out of bound exception. So list.get, get index 1. Index out of bounds exception, and, it will tell you the line that it happens on. Okay, so get is almost identical to, so set, as you might imagine, is almost identical to get. Let's go ahead and copy paste it and change it. So, and just change the variables that we need to. So set, instead of, is going to return, so by convention, if I recall correctly, set will return the item that we're replacing. Okay, just as kind of a nicety, if I recall correctly. Let's go ahead and double check the slides to make sure. I want to just make sure of it, because if I'm working off memory, that's why I have the slides. Okay, yep, so set returns a type E. It returns what was previously there. So public set E item. So this will, returns, so replace, this is item, replaces thing at index with item. Returns the thing being replaced, right? Doesn't have to, it can be pretty brief, somewhat ambiguous, but understandable, so long as it, describes accurately what it's doing. So what we're going to do is pretty similar. Here, we're going to, again, check to make sure it's not out of bounds. That's why I said I could just copy paste a lot of it. We're going to grab the previous item, and I'm going to call it previous item over here, right? And we'll go ahead and return it, right? So we're going to grab the item, the previous item that existed at index 0, and going to store it in previous item. And then at the end of the method, we'll return it, because essentially we want to give the user the option of doing something with it, right? It's just a nicety. Most of the time they're going to throw it away, but sometimes they might want something to do with it. Okay, and now to replace it, because we know how this works with arrays. We just simply say data at index is equal to item. So we take the item and we store it in the index. Technically, of course, what we're doing, as will be more important in ArrayLists, in linked lists, is that we're taking the memory location on the right and storing it in the thing on the left, in the variable on the left. So now we can set an item there. Okay, so long as the index already exists. But we can't really test this one until we can add things to the list that can be replaced. So now we have to actually, work on add. Oh well. So this one we're gonna have to just build up. It's gonna be a couple of phases, but it's not gonna take too long, and they're all gonna make sense. So public void. So public. Not. Let's see. I believe that we have two add methods. We have a Boolean add and a void add. So let me go ahead and write both of them. The signature for both of them. Public Boolean add e item. And I'm just going to put. I want to be all. I always like my code being able to compile. So even if it's. So I just put return false there, even though it's not complete. And then I'm going to write the other one, public Boolean add e, public void add int index, add to the index this item. Now I'm going to leave this one for later. What I'm going to do is eventually what I'm going to do is I'm going to have this one call the second method over here. Okay. Remember, all we're doing is just we're adding. All we're doing is adding an item to the list. If item is, and the type of item, if this is a list of strings, it's going to be a string we're adding to the list. It's if a list of integers, we're going to be adding this e over here will be replaced with integer, right? So that's, so that's what e is. It's just some random type. Okay. So now let's go ahead and just do that. So first we need to check to make sure that basically we're not out of bounds. Okay. Okay. So the first thing is we are going to do is check that out of bounds. So this one's a bit of a different out of bounds check because you want to add it to a valid index or add it to the right or to a valid index, right? So first off, we know that index less than 0, right? We don't want it to be less than 0 no matter what happens, right? Can't add it to a negative. But in the previous examples, we had this dot size is equal to 0, or if this dot size is greater than or equal to index, right? If it's greater, other way around. Bad. This is what happens when I talk and type. If the index is greater than or equal to this size. Now the issue here is that basically if the item is of size, if we are with a list of size 0, we would very much like to add this item to index 0, right? If there's nothing in it, I want to add it to index 0. If there's one thing in it, I would like to add it to index 1, right? If there's two things in it, I would like to add it to index 2. But in those examples, there's no indices. In that first example, where I'd like to add it to index 1, only 0 exists, but it's of size 1. And in that third example, there's two things in it. I'd like to add it to index 2. There's only indices 0 and 1. So if I keep it like this, unfortunately, right, greater than or equal to this dot size, what's going to happen? I'll try to add a new item to index 2 for this list of size 2, and it'll say, it's too big, right? That makes sense? So what we've got here is, right, starting out with an empty array, right? And if I'm trying to add if I'm trying to add 0 into this array at index 0, as it just turns out, this current statement right over here will prevent it from being added, right? Because this array is currently size 0, right? This array list is currently size 0, right? So the way to get around that, of course, is actually pretty simple. We just remove the equal sign. And so it's always valid to add something to index size because that's like the empty space right at the end that we can add stuff to. That makes sense to everybody? You can always add something to the end of it. So now saying I want to add this to index 0. Okay, we'll put it in index 0. What about adding 1 to index 1? What about adding 5 to index 2? Right? So we can always add to the last space because we have to have the ability to add something new, right? Because that space doesn't exist currently, so we have to let it exist. That make sense? I'll work through it on the board after I write this method. So, okay, or after I start writing this method, because then we're going to have to deal with capacity, and that's fine. So, okay, if it's out of bounds, though, regardless of what that is, if it's out of bounds, throw new array index out of bounds exception. Or you could do index out of bounds exception. It doesn't really matter. Just telling the user they're an idiot. That's fine. Okay. 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 Let's assume that this is a valid index to put this item in. That's fantastic. So all we have to do is take this item, right? Take this item, store it in the index of data, right? Take item, take the memory location that's referencing it, store it in data at index 0. So take it and store it in the appropriate slot, and then do index plus plus, right? Just increase the size. So index plus plus, size plus plus. And that increases the size. Okay. So let's go ahead and now let's go ahead and make this a bit easier for myself. If I'm just adding an item, I want to add it to the end, right? So all I have to do is say this dot add. I want to add item to this dot size. I want to add this item at index size, which doesn't exist yet, right? If it's of size 0, we're adding it to index 0. If it's size 1, I'm going to add this to index 1. I want to add it to the end of the array. Make sense? And remember, we can start off by doing that because our array does hold 10 items in it, right? So let's go ahead and run and make sure this works. Yes?
Why is the close parentheses at the end of the add method for this dot size?
Because I've got a getter method. I could easily, that was just me hitting parentheses. I could easily just use this over here. Okay, so where's my error? I have an error somewhere, so let's go and find it. Track you down. No semicolon. Oh, right, and then I have to return true. Well, since adding an item should never fail to an array list, I'll always return true. The Boolean for add is whether it was successful in adding or not. That comes from the collection superclass, and because it's sometimes possible for stuff to fail being added. Okay, so let's go ahead and work and say list.add, and this is a string. We'll add string 0 to index 0, right? That'll make it easy to keep track of, and then 1 to index 1, right? So it didn't crash. Okay, so system.out.println list, which is going to be less than helpful. Why is this less than helpful? Because we have to write a toString method, right? We don't have a toString method, so we use what we inherit from our parent, which is object, which just print out your class name at the hash value, and the hash value is your memory location. So print out your memory location, essentially. And so I guess we have to write our own public string, toString, right? And let's go ahead. There's a couple ways to do this. We can do string. We can build it ourselves. String output is equal to, let's start out with a open brace, right? And then for int I is equal to 0, I is less than size dot, just size, right? This item size, this list size, I plus plus, and because this is a fence posting problem, as you'll see in a second, I'm gonna do less than size minus 1, okay? So we're gonna print out all the items. The last one, output is equal to output concatenated with a one, this dot data I plus a comma and a space. Right, and then the last item in the list, if we had let it go through all the items, it would have had comment a space after the last item, which would have implied something was missing. So, and then return output plus the last item in the list, which would be this dot data I. It's not I, but size -1, because that's always the last thing that's stored in an array. And then add a close brace after that. So now let's run this and see what happens. And we get 0 and 1. Cool. Of course, I could have, been a bit smarter about that and, cheated and used what Java has and simply said, since this is an array in here, return arrays.toString this dot data. And could have totally done that instead. Except that one's going to return 0, 1, and a bunch of nulls. Why is it going to return a bunch of nulls? Because there's 10 elements in there. So actually pretty good idea. Good thing that I wrote my own one there. But that does help us see that it's doing the whole adding to empty spaces thing. But we don't want the user to see that because we want them to pretend it's an array that automatically grows as they need it. Of course, we now run into an issue. Right? For int I is equal to, let's go ahead and switch this up. For int I is equal to 0, I is less than 1,000. I think you'll see the issue very quickly. Right here, very quickly. Plus, so print out we'll print out the items as we add them. Okay, we'll print out the list as we add items to it. List.add. We're going to add I, and we're going to turn it into a string just by concatenating it with a string, right? To the last index. So now run it. 0, 0, 1, and it grows up, and then it says, hey, exception, out of bounds, 10. Right? Because remember, the initial array is size 10. Right? That's our initial capacity, and we filled up our capacity. And so now we're at a bit of a dilemma. Okay? Because now we're headbutting, headlong right into the problem that we said we have with arrays, which is that you can't change the size of an array. Right? But there is just so we're not going to even bother trying to do that. Instead, we're just going to work our way around it. So, okay, my array is too small. So let's go ahead and say if the size of my current array is equal to the capacity. In other words, if there are as many things in the item, if there's as many things in my array right now that I can hold, then I'm going to just keep this method simple rather than making it too complicated. I'm going to reallocate. Okay? I'm going to create a new method called reallocate. And then we still have another problem to solve with this one, but first we're going to handle reallocate. And the other problem, in case I don't run out of time, is, what about the other indexes? Which we'll have to do. Okay, so reallocate. So we're gonna have to create our own private method, reallocate, and it's gonna be private because I don't want people to call this all willy-nilly. And what this is gonna do is that this is going to make more space for us. Now we can't create an array, so we can't extend the length of our array. But what we can totally do is make a new array, right? We can make a new array, a bigger array, a better array, twice the size of the original one, and just copy everything over. So that's what we're going to do, right? We are just going to silently kind of cheat here by just taking everything in the old array and moving it over to the new array. Okay? I know, that's like a super simple hack, right? It doesn't even merit the term hack, but that's how array lists work. If we got too much space, if we don't have enough space, well, we make more space and move everything over. So that's what we'll do. Okay, so we'll say that. So let's go ahead and do this. Old array, so old data is equal to data. So we're going to store all of our old stuff in old data for right now, okay? we're going to store all of our stuff in old data, right? So it's just there. Then what we're going to do is we're going to create we're going to say that data, our array, is equal to a new array, well, we'd love to say new E of twice the size. First, let's go ahead and say capacity. This dot capacity is equal to 2 times capacity, or as we can just simply say, times equals 2, which will just double that. Okay, so let's double our capacity, and then we would love to say capacity over here to create a new array twice the size, but we cannot because we can't create a generic array of E's. So what we're going to say is that it's an array of objects, right? And then we're going to tell, well, pointers are references are references anyway. So actually, we're just going to store this. We're going to do this casting over here, and that's going to be fine. So see, we've stored all our old values, right? All our old data. And we're going to create a new one that's twice the size. Okay? And now we just copy everything over. So for int I equals 0, I is less than, so let's see, I is less than old data dot length. Let's go and be safe, and actually let's go with size because there's going to be size things in there. I++. Okay. Okay, we're going to do that, and now we just copy everything over. We say data I should hold old data. We're going to take the thing in our old array that was too small and move it over to the new one, right? And we've increased the size of our capacity so that this doesn't trigger every time. It's only going to trigger basically whenever we're filled up. So whenever we need to double the size. And we're just doubling the size as a good rule. We want to increase it by some big amount. We don't want to increase it by 1 because otherwise we'd have to create. If we were doing this instead of times equal to, and doing plus equals 1 instead, and just creating a new array of size 1 bigger, that would be a bit of a pain because what's going to happen? Every time we add 1, we're going to have to create a new array and copy everything over, which, as we'll find out, is very inefficient. So by multiplying by 2, we copy everything over that we need to, and we hopefully basically delay doubling for as long as possible. Disadvantage, as we'll see, is that this can waste some space, right? We can just have some empty spaces just hanging out in the middle of nowhere. And that should answer the question of why would you want to use an array over an array list if an array list can automatically grow? Well, because array lists can have some extra stuff hanging out nowhere. So we're going to reallocate, and then we're going to copy everything over. So now let's go ahead and run this, and it's working just fine, right? So all we did was simply say if size is equal to the capacity, if we need to double it, then double it. Ow, still getting used to it. If size is too small to hold new item, right? If the size is too small to hold the new item, reallocate, which doubles the capacity, right? Okay, so now this is almost entirely working in regards to add, okay? The only issue is that I didn't really get it working, which is what if I want to add stuff to, like, sorry, wrong area. What if I wanted to totally, actually add stuff, not to the end of it? Say I wanted to do, I wanted to add everything in reverse, so put everything in front. Add I plus that. But I want to add it to index 0. So it's going to be 0, then 0, 1, then 2, 1, 0, right? Because I'm adding everything to the front, and it's going to push everything over, right? Well, it's not pushing everything over, right? Because I don't have code that's pushing everything over right now, right? I just have stuff that's replacing the very first item in the list. Bit of oversight there. Oops. So I guess we're going to have to write that. Now, we have 4 minutes left in the class, so that's, well, 3 minutes now. So that's not enough time to write that. But after that, let's go ahead and just set ourselves up for the next class, which is, besides add, what else do I have that we need to implement for next class? Public. So public Boolean, public Boolean contains. I would say it contains item, right? Does this have it? Public index, so public index of an item. And of course, public remove int index, which removes an item from an index. Those are the those are the 3 items that, these are 3 things that we need to use. So return false. Return -1. And I'm just squashing the errors. Return null. So these are the 3 things that we need to write for ourselves. Okay? So that's, I think, a pretty good lecture for today. Pretty good space. I'm surprised that we've already, not caught up and definitely passed the evening lecture, but I'm going to double check to make sure I didn't skip anything over that I feel like you guys need to know. Because I do try to bring them into parity so that basically it works like so Monday, Wednesday is the first halves of the Tuesday lecture, first and second halves of the Tuesday lectures respectively. But I don't know, it seemed to work pretty well that we caught up. And then once we finish this, we'll get into how do we write like static methods that use array lists. That will be on Wednesday, and then on your lab, you're actually going to get some standard exercises in using those. So nothing like too hard, nothing project, just more like exam questions, like this method takes an array list, make it do this. Yes. Right. When I'm saying homework, I'm referring to lab. Also, you should probably expect that you'll have a quiz on Wednesday. Yep. We'll give them out on pretty much every week. These are the 5% quizzes. The quizzes are 5% of your grade. You will get 6 to 7 points just for showing up. So, out of 10. Out of 10. As I said, these are mainly for participation. So they're not something meant to stress you out, right? So you get plenty of credit just for showing up. It would be like it during the first 10 minutes of class, or after at some acceptable midpoint in class.
Wednesday?
Yeah, on Wednesday. So bring a phone, bring something that can access Canvas. Because
It's just on the ArrayList.
yeah, it's just gonna be on list stuff.